we turn our attention to simplifying square roots. Now we are not going to be using a calculator. The square root of 50 we know is a little bit more than 7, because the square root of 49 is equal to 7, and this is just a little bit larger than the square root of 49. But if we were to use a calculator and get 7 point something, at some point we'd have to round and that answer would not be exact. What we're going to be doing is having an exact answer. And to solve these problems, or to simplify, we are going to take our 50 and perform do a factor tree. Breaking that number down using multiplication, we're going to have 5 times 5 times 2. Now, a square root undoes squares, and what I've just circled here with a pair of 5s is really a 5 squared. And so my answer is going to be 5 square root 2, because the pair of 5s, that 5 squared, has been square rooted, and that comes out as a 5, and the 2 cannot be rooted on its own, and that stays inside the radical as root 2. Now I've got kind of a cheesy analogy here, but think of an ice skating rink or a roller skating rink where there's pair skate, and you can only go out on the ice if you're in a pair. Here's a pair of 5s. The DJ says it's time for you guys to go out for pair skate, and so boom, they go out on the ice or the roller rink, and they must hold hands, so they're kind of considered a single grouping running around or rolling around the rink. Whereas the 2 does not have a partner, cannot come outside of the outside boundaries, and must stay inside. Kind of a cheesy example, but it helps you to remember what you're doing here. Let's move on and square root 108. Think of a multiplication problem that makes 108, and I'm thinking in my head of 9 times 12. 9 breaks down to 3 times 3. 12 breaks down to 4 times 3, and that 4 becomes a pair of 2s. So I've got a pair of 2s and a pair of 3s. They each contribute 1 of themselves, so we have a 3 and a 2 coming out, multiplying together to make a 6, and then we've got a 3 left over which stays inside the radical, and we have 6 root 3 as the answer, or simplified form. When cube rooting 54, we're no longer looking for pairs, we're looking for 3 of a kinds. I'm breaking this down into smaller prime numbers, and now I'm going to have a 3 of a kind of 3s. That 3 of a kind is going to come outside, give you a 3 on the outside, and then left over inside the cube root is the 2. Don't accidentally forget to leave out that index of 3 in your answer. So, the index tells you what of a kind that you're circling to bring out of the radical. Now we get some variables involved. 98 isn't a variable, obviously. We're just going to break the 98 down normally. I'm going to go 2 times 49, keep the 2 there, break the 49 into 7 times 7. So I do have a pair of 7s coming out, and then I have to turn my attention to these variables. Now the long way of doing this is to say, oh, I got 5 A's, A, and I'm looking for pairs like that. It works, but what if that wasn't a 5? And with the B's, B, 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 you can see that I have 3 pairs with 1 left over. So our answer here is going to be 7 coming out. We've got 2 A's coming out, so A squared. We've got 3 B's coming out, so we're going to have B to the 3rd. Then left over inside the square root, there's a 2, an A, and a B. Now, technically, if there weren't a restriction on this problem saying, ooh, watch out for absolute values, watch out and assume the variables are positive, we might need to force that b to the third to be positive using absolute values. I only mention this, I probably won't mention it again, because usually there will be a disclaimer. Now I mentioned there's got to be an easier way than doing all this circling stuff. And that easier way is to understand that we have an index of 2 in this problem. We take each exponent inside, 5 for starts. We divide it by 2 and we get 2 remainder 1. Then we take the 7 inside, divide that by 2, and we get 3 remainder 1. The remainders are what stay inside, and the number of times that 2 goes into this number out front is how many pairs or how many are going to come out in front of the radical.